today, first of all, is that we can write and use rates and unit rates. Okay, we use rates a lot in everyday life. We especially talk about them as unit rates. So we have to make sure we have an understanding of them. And then one of those ways of using rates is finding, like if they want us to put something in a different rate, is like we typically talk about the speed that we're driving a car as what? Miles per hour. Okay, but we can also measure rate in other, measures. So we could be like feet per second. It could be meters per minute. I mean, there's different ways that we can measure that. And so that's when we get into the dimensional analysis, where we're using rates to help us convert. So a rate is a ratio of two quantities with what? You don't say.
Proportion.
No? What's true about the units in our ratio? So it's a ratio, so we know there are two things being compared. We can write it as a fraction, Tyler? Different rates. So when we talk about a rate, we're talking about them having different units, So a rate is a ratio where the two things being compared are different units. We're not comparing miles to miles. We're not comparing, dollars to dollars. We're comparing two things that have different units involved. And they're usually written as unit rates. So we don't typically talk about how much somebody makes per every 3 hours that they work. How do we typically talk about it? Per hour, yeah, or how much somebody gets paid per month, or however, we don't talk about it in bigger units. We talk about it as unit rates. So the second quantity is usually, when we talk about unit rates, the second quantity is 1 unit. So here are some examples. Notice the second thing in the comparison, and all of those are 1. So it's per 1 gallon, per 1 hour, per 1 gallon. Okay, so what would we fill in the blank here? How many quarts are there in every 1 gallon? 4. So that is a unit rate. 4 quarts to 1 gallon. 4 quarts per 1 gallon. That's considered a unit rate. What would we fill in the next blank with? How many minutes in an hour? 60 minutes in 1 hour. So there's another unit rate. 60 minutes for every 1 hour. Okay. And what's this last one? How many miles per 1 gallon? What would we fill in there?
Varies.
It varies, doesn't it? According to what?
The type of car.
Type of car you're driving, how fast you're driving. Yeah, so we're going to have to put an X there. But it's per 1 gallon, so we still can talk about that being as a unit rate. And we know that definitely can vary. That's one of them. The how many minutes in an hour, that doesn't vary. How many quarts in a gallon, that doesn't vary. We can have miles per gallon vary because of the things we said. So to find a unit rate, set up a ratio in proper order and simplify. So again, we want to make sure that we talk about it, correctly. We just said if you're getting paid by the hour, first of all, we don't talk about how much you get paid for every 3 hours. We talk about how much you get paid every hour. And another way we don't talk about it is we don't say, oh, for every 1 hour, it's this many dollars. We say this many dollars per hour. Okay, so we want to set the comparison in the way that makes sense. So if we have 12 gallons of gasoline that were used to go a distance of 222 miles, what is the number of miles per gallon? We're basically telling you right there the order to set it up in. So what should be first in our ratio?
Miles.
The miles. So we should put our 222 miles first in our ratio. And downstairs, we're going to write them as fractions. And downstairs we would put what? 12 gallons. In this case, they went 222 miles on 12 gallons of gasoline, but we're supposed to give it per 1 gallon. In other words, we're supposed to change it to a unit rate. So you might want to get your calculators out. This is kind of one of those assignments you're going to probably want your calculator for. And of course, you're supposed to bring your calculator every day. So let's show what we're gonna actually put into our calculator before we do it though. We're gonna put in 222 and divide it by 12. And if we have to round, they'll typically tell us what to round to, but I don't think this one should have to be rounded. Go ahead and divide that out. What do we get? 18.5 or 18 and a half. And what would the label on that be?
MPG.
MPG. It could be MPG is one way we could write it, miles per gallon. Or we could write it as miles, MI. And you have to put the I behind it when you mean miles, otherwise the little M means meters. Yeah, so miles, we put the little I behind the M, and then gallon, it's GAL, if we do it that way. Okay, so we can do it, we can label it either way. So that is considered a unit rate, isn't it? Because it's per 1 gallon. Okay. How about this next one? Corey earns $52.50 in 7 hours. Find the unit rate in dollars per hour. What would our setup be? What would our ratio be, first of all? Because we're going to set up a ratio to show our rate. What would this one be? What should go upstairs?
52.50.
Yeah, the 52.50 should be upstairs because we need dollars per hour, and we'll put 7 hours downstairs. We will show what we're going to actually divide out in our calculator. And see if it divides out nicely or if we have to round to the nearest. What are you supposed to round to when it's money?
Dollar.
No,
Or cent.
cent, yeah. Chances are you're going to want to get paid for every penny that you earn, right? So if it's 49 cents, you're not going to want them to round you down to the nearest dollar going the other way, are you? Okay, so Riley,
Oh, I know the answer.
do you, okay, what is it?
$7.50.
$7.50?
Yeah.
Okay, so the dollar sign goes in front of the 7.50, and we don't put 7.5 because representing money, 50 cents, and then it's per, and we can use the fraction bar for that, hour. An hour, we typically, I think they have kind of started using the abbreviation just H also for hours, but I still use HR. Okay, any questions so far? Okay, go ahead and do this last one then, on your own. This is the kind of work you need to be showing in your homework also, or you can't use those calculators. Okay, what are we really actually figuring out right here? When we get this unit rate, what's it telling us? What's this unit rate telling us? Aaron?
How many miles we given an hour?
So what else though? What does that mean, miles in an hour?
How far you've traveled?
Well, how far you travel in 1 hour, but
Miles per hour.
miles per hour, which is what? Speed, how fast you're going. Yeah, this is how fast this car was traveling. When we figure this out, it tells us how fast they were going. How fast is this car going?
73 miles per hour.
Okay, 73 miles per hour, and I think typically that's usually how we'll always see that one, MPH, right? We could write it MI, fraction bar, HR, miles per hour. Yep, we could do it that way also. It's just that more typically you will see it written MPH, okay? So unit rates. Now be careful. Here's what students tend to do with rates. They tend to take the first number that was given to them, put it upstairs, take the second number that was given to them, put it downstairs, divide it out, and just go with the answer. Are they always going to give it to you in the order you should set it up, do you think? No, you're going to have to decide what makes sense. How should I set this up? Does it make sense to talk about hours per mile? No. Does it, we don't talk like that. We talk about miles per hour, so we gotta make sure we set it up accordingly. So anybody have any questions on rates or unit rates? Okay, let's go on to our dimensional analysis. This is always the one that's a little bit more challenging for students. Using dimensional analysis, multiplying by conversion factors. In other words, we're going to set up rates that we can use that will help us find a rate of different units. In other words, if they don't like what it was given to us and they want us to convert it to something else, how are we going to do that? So we have a cyclist that's traveling 56 miles in 4 hours. Find the cyclist's speed in feet per second. So if we just divided it out right now, we set it up right now and put like 56 miles over 4 hours, what would we be getting? We get the miles per hour, wouldn't we? But they want it in feet per second. Well, here's what students like to do. They like to just start dividing and multiplying and, and hope that in the end they get the right answer, or at least get an answer, and then they just write that down in our, hopeful that it's the right one. We're going to show multiplying by rates, okay? So let's start with setting it up the way it should start, with the distance being upstairs, being the first in the comparison, and use the labels, and the time being downstairs because it's distance per time. And we need the miles to change to what? Feet. And we need the hours to change to seconds. Okay, so we kind of need, can we go straight from miles to feet, by the way? Is there a conversion factor from miles to feet? Yeah, there is, isn't there? Okay, so let's take care of that one first. We're going to do them one at a time. So let's multiply by another rate that would get rid of the miles for us. Anybody think they know a ratio we could set up that would help us get rid of the miles in this? They could get the miles to cancel out. John?
1 over 56. Multiply by the reciprocal.
So multiply by the reciprocal of this?
Yeah.
So 4 over 56?
Yeah.
Okay. So if we multiplied by the reciprocal, let's see what would happen. What would happen? Well, the miles would cancel each other. The hours would cancel each other. The 4s would cancel each other. The 56s would cancel each other. What would we have? 1. Do you think that's the answer?
Yeah.
No, probably not. Sage?
5,280
But-
over 1.
Okay, 5,280 what? Feet. Okay, so I got to get my miles back here over my hours, and then I'm going to, so you want me to do 5,280 feet, I think I heard, over 1 mile. Okay. So Sage, could you tell us why you set it up that way?
There's 5,280 feet a mile.
Okay, there's 5,280 feet in every mile. Do y'all agree with that?
Yes.
Okay, well, Sage, why couldn't we just do it the other way? Why couldn't we put the miles upstairs and the feet downstairs? Why shouldn't we just do 1 mile over 5,280 feet? Because isn't that the same thing? In 1 mile, there's 5,280 feet. Jeff, what do you think?
So cancel out the miles.
Yeah, we need the miles to cancel out. So we could flip this if we needed to, but we need it this way because our goal is to get these miles to cancel out. We can't have 3 different labels in our rate here. We can only have 2. So we're going to have feet per hour now, aren't we? Okay, so what would we do? In fact, here's what I want you to do. I want you just to, calculate this one, and then we'll move on to the next, so we don't have such big numbers to work with in the end. So we have a couple of different ways we could go about this. We could see if 4 goes into 5,280, or we could just multiply straight across and simplify later. What do you want to do? Okay, let's just multiply straight across. So we're going to take 56 times 5,280. Would you do that, please, on your calculators? 56 times 5,280.
295,680.
680? Okay. Okay, what are those right now?
Feet.
That's feet, because that's the label left upstairs. And then downstairs, we have 4 times 1, well, we don't need a calculator for that, and that would be what label?
4
Hours. Okay, so if we stopped right now and divided this out and said, okay, 295,680 divided by 4, we could change it into a unit rate, what would it be? Don't give me the answer, but what would its label be? What would we have? Feet per hour. Is that what they want? No, they don't want feet per hour, do they? So we're going to carry this down to the next line, and we're going to, I think I'll use green here, and we're going to write this one down, and we don't want to ditch the feet, we want the feet, right? That's what we want in our final answer here. It says feet per second. So we don't want the feet to cancel out anymore. We don't want to change those to inches or anything, right? But we want to get the time changed to seconds. So we're going to do it, one factor at a time. So let's go from hours to what's the next smaller unit of time? Minutes, okay. So can somebody give me a conversion factor we could use that would get the hours changed to minutes in this? Tyler? 60 minutes over 1 hour? Y'all agree?
No. 1 hour, 6.
Yeah, we need the hours to cancel out, don't we? So that's the first decision you always make is where do I need those to be, upstairs or down? I need them up so they'll cancel. So if I put the 1 hour upstairs, that means the 60 minutes goes downstairs. So we don't always use our conversion factors as unit rates, okay? In other words, sometimes the 1 has to go upstairs instead of downstairs. Okay, and now we can say, oh yeah, the hours are going to cancel out, 1's up, 1's down. And now we'll multiply straight across again. We have 295,680 times 1, so that stays 295,680. What are those? Feet. And downstairs we have 4 times 60.
240.
240. And those are minutes, okay? So could we stop now and divide it out and say we have our answer, feet per minute? No, we need feet per second, so we're going to keep going. 295,680. Now, in your homework, you don't have to stop and keep doing it on every line like we are, but in your notes you want to be able to follow what we were actually doing. But I do need to see the conversion factors. I don't want to just see multiplying and dividing. I need to see if you want to make it one big long multiplication problem, you can, without those stops in between like we're making. Okay, what is it we need to go away now? What is it we're trying to get rid of? Minutes, okay, so what do we want to, give me a conversion factor we can use this time.
60 seconds in a minute.
There are 60 seconds in 1 minute. Where do we want that 1 minute to be, Noah?
Upstairs.
Upstairs, because we need those minutes to cancel out. So we'll put the 1 minute up and the 60 seconds down. And now the minutes will cancel. And I'm thinking we finally are really close to having this done. We have feet upstairs, seconds downstairs. So let's just multiply across right now. 295,680 feet over, what's 240 times 60?
14,400.
Okay, is 14,400. You guys agree? Okay, 14,400, and those are seconds. Okay. Well, we are finally ready to do our division, aren't we? 295,680 divided by 14,400 equals. And I think it said up there to round, it says round your answer to the nearest 10. So we're going to have to use the approximately equals to symbol because we're going to round. Whenever we round, we use the squiggly equals.
20 and a half.
And we got to know how to round correctly. So what is it?
20 and a half.
20.5? 20 and a half? Okay, everybody agrees? Look at the hundredths place, decide if the tenths place should stay what it is or if it should round up. And what had to happen this time? Did it stay the same or round up? What's in the hundredths place?
3.
A 3. What's in the tenths place?
3.
That's a 5.
A 5. So we didn't change that 5 because a 3 right behind it is not big enough to round it up to 6. And these are feet per second. So we could do FPS, or we could state it as feet per second. And I think seconds are also something like hours or something. That is an S, not an SEC too. Okay. So when you're doing these, okay, here's what, let me show you what would for sure have to be shown in a problem like this in your homework. Let me circle everything for you. It would start right here. Here's multiplying by the first conversion factor. If you don't want to stop and do the multiplying, then you could multiply by the next conversion factor. Then you could multiply by the next conversion factor. And then you would get this. And then you would show what are you doing in your calculator. Yeah. Because you and I better be able to follow your train of thought without you saying to me, I don't remember what I did. Sage.
Could we have just, instead of doing 1 hour over 60 minutes and 1 minute over 60 seconds, could we have just done like 3,600 seconds over 1 hour?
Well, you probably wouldn't have wanted to do it in that order, but
Right.
yes, you can combine a conversion factor. Yes, so if you know that there are 3,600 seconds in every hour, you can combine that and make it one conversion factor. Yes. Okay. Anybody else? Any questions for this dimensional analysis stuff? Students love to try and convince us that they know how to do these and not have to show all this, because you know what? I know what I'm doing, but yet they don't give the right answers. Because sometimes we don't, as we're trying to do it, we can't decide if we should multiply or if we should divide. So when we set them up as conversion factors like this and just treat it as multiplication all the way until the very end, it typically works better. Okay? Okay, let's do one more problem. Let's solve a proportion here. Give me the cross product setup for this one. What would it look like? To help us be successful, we have to have a good start. What would this one look like to start with? Multiply by the reciprocal? No, I want to do cross products. We could multiply both sides by the reciprocal, but then what's going to happen? Which reciprocal are you going to use? Which side's reciprocal? Yeah, it's a good question. And then when you do that, you know, chances are you're going to end up with a 1 on the other side, and then you're going to have variables upstairs and downstairs, and a fraction you're going to kind of be lost there too. So I'm thinking that you might want to stick with cross products. So give me one side of the cross products. John?
5 multiplied by n minus 1.
Okay, so like this.
Parentheses.
What has to be in parentheses?
N minus 1.
The n minus 1 has to be in parentheses. It has to be. It has to be. And then what would the other side be? Same thing, 5 times n minus 1 in parentheses. Oh, you mean 2 times? Is that what you mean by the same thing? Oh, okay, go ahead then, write that. Do your distributive property on both sides, solve for n. You do it yourself. Same thing happened to you as happened to me. I'm at the point I have n equals, and I'm saying to myself, 11 isn't divisible by 3 nicely. Did I do something wrong? Not necessarily. I could have, but not necessarily. Just because we don't get a multiple of 3 doesn't mean it's wrong. So how could I, what are the different ways I could show my answer for this one? What's one way? Brendan?
Decimal.
No. Why not? Why am I not going to let you show it as a decimal?
It's probably
Because it's not a nice decimal. Go ahead and do it on your calculators. What is 11 divided by 3?
3,
Oh, my.
6, 6, 6.
Oh, 3.6666666, and all of a sudden it does a 7. So is that what you're going to write down on your paper? Well, what are you going to do then if you're going to write it as a decimal?
3.6 repeating.
Oh, it would be 3.6 with a repeating bar over the 6, but then if you had to do a check problem, what if I said, oh, you have to do a check problem? How would you check with a 3.6 repeating in there for n? Anybody know how they do that? Would you just write a bunch of 6s so you decided, well, that's enough of them now and I'll just work with those? Or would you just write one of them and say good enough? Or what would you do?
6 repeating.
6 repeating. How are you going to check with a 6 repeating? You really don't. You got to use it as a fraction. That's right. So this is not a nice decimal. We're not going to give this one as a decimal. Sorry. So give me another choice. Riley?
3 2/3.
3 2/3. That would work. What would be another choice I would allow? Brendan?
Just 11 over 3.
Yeah, just leave it as its improper fraction name. Okay, either of those would work, but don't give it as a decimal when it's not a nice decimal, okay? So, we could have either of those. You don't have to have both, but you could have either of them. Okay, so, it actually wouldn't be fun to check it with this answer, but you still could check it. Whereas if we change it to a decimal name, that would be much more challenging to try and do a check problem with